we're going to take a look at finding the magnitude of a vector. Okay, so as I said in the previous video, the magnitude of a vector is just the size of the vector. Okay, it's how big the vector actually is. Okay, and really, to calculate the magnitude of the vector, it's really just us using Pythagoras' theorem, because a straight line can always be found by the horizontal and vertical components. So if I was to find the size of vector u here, if I start from here and end up here, giving your journey in terms of a vector, it would have a component of A going along the x direction, and then a component of B going up the y direction. And because the x and y axis meet at right angles, it forms a right angled triangle. So really, if you know the size of your horizontal and vertical components, then all you need to do is just end up doing the Pythagoras on the components here. For magnitude, we give the magnitude a denotion of the letter with lines on either side. So if I want to find the size of vector u, then all I'm going to do is I'm going to find the square root of the components squared and added together. So in this case, it would be 4 squared plus 3 squared. So that would give me the square root of 16 plus 9, which would be the square root of 25, which is going to give us 5. And that is Pythagoras' theorem. It's Pythagoras' theorem without us saying the very first line. Okay? So let's relate this to the diagram that we have here. So let's say that for vector u, we have the A component is 4 and the B component is 3. If I'd ask you to work out the size of the hypotenuse side, I would expect you to say that u squared is equal to 4 squared plus 3 squared. All this is doing, the magnitude formula, is writing it in a slightly different way. So usually we would go ahead and process 4 squared and 3 squared and then square root. All that's happening here is they are taking the square root over first of all and working out 4 squared plus 3 squared underneath it. Okay? Let's look at example B. I want to find the magnitude of vector v now. So that's going to be, so mag v, it's just the v with 2 lines on either side, is going to be the square root of 5 squared plus negative 5 squared. So that's going to give me the square root of 25 plus 25, which will be the square root of 50. And if you get subbed, you must always make sure it's simplified as far as possible. So root 50 is the same as saying root 25 times root 2, which will be 5 root 2. Okay? Example C, let's find the magnitude of vector PQ. So I can say that the magnitude of PQ is going to be the square root of negative 4 squared plus 8 squared. So that's going to be the magnitude of 16 plus 64, which will give me the square root of 80. Simplify or subbed, so that's going to be root 16 times root 5, which will be 4 root 5. And finally, the magnitude of vector RS. So mag RS is going to be the square root of negative 3 squared plus negative 6 squared. So that's going to be the square root of 9 plus 36, which will give me the square root of 45. Find the square root of 45, so simplify your subbed. That will be root 9 times root 5, which will be 3 root 5. Remember, if your sub can be simplified, then you must always simplify it. And that is finding the magnitude of a vector.